contributes about 30 to 70% of total site energy, and only a small portion of input energy is actually used to produce new surface area, while the rest is lost or dissipated as heat energy, noise, vibration, overcoming friction, and what have you. So with this in mind, even the small or slightest improvements in communication efficiency translates into huge cost and energy savings because of the massive scale of energy use. And communication is very important because, as we see, I don't know where you are, probably sitting on a chair, on a bed, whatever, everything around us has metallurgy. So for us to get aluminium, iron, copper, gold, potash, and what have you, we have to go through comminution so that we can get these materials out of the raw ores. They need to be processed before we can get them to build our bridges, have a hospital equipment, computers, mobile phones, and whatnot. So our objectives for today, we'll be moving from the problem, why the high energy use, to the fixes of why it happens, and finally to the discussion of solutions that can be implemented. And then last but not the least, examine some of the challenges and future directions. So over here, you can see a schematic representation of valuable mineral liberation after comminution, sorry. So this is the ore body, and after breakage or comminution, realize that the valuable mineral is liberated from the gang material in the ore body, right? Okay. So, typical energy consumption breakdown. We want to know the breakdown of comminution energy. When you look at the crushing and grinding. So we have some overview here. The fundamental issue is that the breakage mechanism in crushers and mills are not selective. Energy goes into the energy that goes into the process, like I mentioned earlier, most of them are dissipated as heat, vibration, noise, kinetic energy, overcoming friction, amongst others, except into the useful breakage. So as the ore hardness increases, or the smaller the particle size that is required, energy demands increases exponentially. This explains why grinding alone often consumes 30 to 50% of site energy. However, we should know that these percentages vary depending on the ore type, the circuit design, and the throughput, but the trend is consistent across the industry. Grinding is the largest single consumer of electrical energy at mine sites, especially the SAG and the ball mill configurations. Highlighting this breakdown shows why improving comminution efficiency has the highest or the largest potential impact in saving energy. Also, it saves costs and carbon footprints as well. So with the inefficiencies in traditional comminution, when I mention traditional comminution, I'm talking about the use of the sag mill and then the ball mill. The mode of operation of the traditional or the conventional mode of comminution is mostly by impact breakage. And with impact breakage, it's normally random, right? So it does not stress particle enough to break them. All these inefficiencies compound each other. And also, we look at the classification of inefficiency. A load can also double circulating loads, increasing mill work. When you talk about classification inefficiency, looking at cyclones, when you talk about classification, we know about cyclones and the streams, right? So if, especially at the mill, we know that from the mill, we go to cyclones or for classification purposes. So if it is inefficient there, it keeps recirculating back to the mill. So that gives it a double circulating load. It causes overgrinding, and it is really not efficient because more energy is required and is being used. Again, older circuits lack real-time sensing, so they operate conservatively rather than optimally. It is the process is not optimal. And then there is also the all variability bit of it, where it is common in most mines, a major but often an unappreciated contributor to inefficiency. Because maybe we take in a month, first week, second week, the ore that comes from the pit to the run-off mine that goes through the beneficiation plants, the variability of the ore is not all that hard. So that is how the operator in the control room has set or is running the processing plant on. But along the line, if we have an ore body that comes into the plant that has variable characteristics and it's much more harder, it's difficult to know if tests and other measures are not put in place. So that also causes or is a contributor to using a lot of energy when it comes to the comminution process. So we've spoken about how the energy inefficiencies of the traditional combustion processes, which is a sag mill and a ball mill, are. Now we are going forward. We are going to talk about some of the main technologies that are currently being used to improve energy efficiency in combustion circuits. The first one I would love for us to talk about is the high pressure grinding rolls, otherwise known like abbreviated as the HPGR, which is used as a mining efficient size reduction method that uses two counter-rotating rollers to compress rocks and ores, causing them to break apart from interparticle forces rather than from external forces, right? So for the mode of breakage when it comes to comminution, we have impact breakage that is being employed in the sag mill and in the ball mill. And then this one has compression. The rock or the ore body is broken down by means of compression of these counter rotating rollers, as can be seen in the schematic representation over here. So this helps us get low circulating load, improve circuit stability, and is ideal for competent or hard ores. And it also applies interparticle compression. Like I said, it uses compression and not impact or abrasion. So instead of impact, it uses compression. And then HPGRs are increasingly being deployed as a replacement for sag mills or as a first stage in hybrid flotation, sorry, not flotation, in hybrid flow sheets, such as the HPGR is introduced first before it's followed by the ball mill or the stirred mill if fine grinding or ultra fine products are expected or want to be realized. Secondly, we want to look at the stirred mills. We have the ISA mills, so the SMD. SMD is the stirred mills, detritus, and then the vertimill. So this uses attrition and shear forces. Like I mentioned earlier, the ball mill uses the impact, the HPGR uses compression, and then the stirred mills uses attrition and shear forces. So as you can see in figure 4 in the schematic representation over here of a stirred vertical mill from from the slide, you can see that it is so the stir mills are grinding machines that use high-speed agitators, right, to move grinding media like balls or discs, which then crush, shear, and grind materials into fine powders. They use small media and high intensity mixing, giving them at least 40 to 60% lower energy consumption compared to ball mills in fine grinding applications. And then one of the additional advantages is it has lower media consumption, a narrower particle size distribution, and excellent downstream recovery performance due to better liberation. When you talk about advantages of having lower media consumption, with the traditional or the conventional method, which is the ball mill and the sag mill, it needs to, with the ball mills that are used as the grinding media or the rod mills, are mostly like the turnover is very high, need to be changing them, and all of these amount to the cost of comminution, right? Aside the energy bit of it. So we have the vertimills, which is used as a secondary or tertiary grinder, and then the ISA mill takes in less than 20 micrometer feed product. Again, we look at ore sorting and pre-concentration. So ore sorting and pre-concentration improve energy efficiency by rejecting low grade or barren material before it even enters the grinding circuits. This directly reduces mill feed tonnage and can cut comminution energy by 20 to 50%, depending on the ore being introduced and or the heterogeneity of the ore. And the most energy efficient grinding is the grinding you do not do. The most energy efficient grinding is the grinding you do not do. So as can be seen here, this is a simplified flow sheet. This is a simplified flow sheet showing ore sorting between crushing and grinding, enabling early waste rejection. So the limitation of the ore sorter is you can't introduce boulders, right? So from the run-off mine, that is the run-off mine, um, the ore is introduced into the crusher to be broken down into a particular or specified particle size, and it is introduced into the ore sorter. With the ore sorter, it uses technologies such as SRT, SRF, optical and laser sensors to reject or take out the gang material, the waste material. So the material that is introduced or transitions to the grinding circuit is one that has high grade or is devoid or has little waste material. So, like I said, the most efficient way to ensure that grinding has good energy benefits is the grinding that we do not do. We get rid of the waste material even before grinding takes place. This ensures energy savings interventions like are realized. Last but not the least, we have the microwave assisted comminution. This is what I did during my PhD at the University of Alberta. My main focus was on microwaves. So one will ask, why use microwave when you can just throw the ore body or the ore material into a conventional oven? I mean, it's all heating, right? But it's imperative to know that microwave radiation encompasses the range of the electromagnetic spectrum between 300 megahertz and 300 gigahertz. Um, it has the ability to convert electromagnetic energy to heat, and as such, heating of a material generates volumetric heating, which helps to decrease both the power consumption and the time of processing. We're talking about the residence time when it comes to milling or grinding. And then also there is the uniformity of heating and ensures selective heating and consumes less energy. So microwave heating of ores is also highly dependent on the dielectric properties of the mineral contained in the ores. So for example, let's take an ore body, a gold ore body. When you have an ore body that's the gold, that gold is the beneficiary mineral. It doesn't mean that the ore body contains only gold, but it's because gold has higher concentration in that ore body, right? So what happens is for a gold ore like this, I'm using gold because I know that is what is primarily like found in Ghana. Yeah, for a gold ore like this, you have the presence of iron, you have the presence of molybdenum, a bit of silver in there, and some other trace metals. So the differences in their dielectric properties of all these different minerals that can be found in the ore body helps with the microwaves because some of them heat better than the others, right? So these fluctuations in temperature while the ore body is being or the rock material is being heated causes breakage or cracks in the ore, which weakens it. So before it even gets to the grinding stage, it's already weak, and as such, less energy is needed or required to break it down to the required or appropriate size for downstream processes. It has significant potential for ores containing minerals with high dielectric constant, like I mentioned. The higher the dielectric constant of the minerals found in the ore material, the better the microwave benefits that particular ore has. This makes it a promising future for energy saving technology. So this is a table comparing all the technologies that we've just seen or discussed. So you have the HPGR, all sorting, stirred mills, and a microwave assisted comminution. We realize that all sorting, like I said, the most efficient energy saving is the grinding or milling or comminution that is not done. Once we take out the waste, we have like little throughput that has to go through the mill, the processing plant or the beneficiation plant, and also the stirred mills like this. So we have 20 to 50% reduction in energy, and then 40 to 60%. So this is just a summary of all that we've just discussed. Now, from all the technologies and strategies that we've just discussed, of course, like I mentioned, it has its own challenges and barriers. Although these technologies offer significant energy reductions, there are several challenges that often limit their adoption and employability. The first one want to look at is the capital cost. Technologies such as HPGRs, microwave systems, or large-scale oil sorters require substantial upfront investments, and many operations struggle to justify the capex of it, especially if the mine life is limited or commodity prices are uncertain, as we normally see in the stock markets every now and then. And there is the integration complexity is also another barrier. Retrofitting new equipment into existing communication circuits can require major layout changes, additional infrastructure, and downtime. Plants often operate under tight schedules, making shutdowns very difficult. There is no time for them to, because if you do that, you're losing money, right? To change things here and there, and it's also very costly. All variability is also a key issue over here. Like I mentioned, technologies like the HPGR or all sorting perform best under stable feed characteristics. You have to be sure about the characteristics of the feed you're introducing into the combination equipment in our machine. Changes in ore hardness, mineralogy, or particle size distribution reduce the performance, sorry, of these equipment, even though they have really high energy saving ability. So it is imperative that we have advanced process control systems in place to take care of all variability. Another point that we would want to look at is the operational readiness. And I mean, at the time when I used to work in Ghana, when I met some of the operators around, they used to use the term MBA, Mebayache. I've been here for a while, so it's like a routine work for them, right? So if you tend to now introduce new technology, new equipment, and all that, you should know that these new technologies need trained personnel, need experts, advanced control tools, and consistent maintenance practices. And all this takes time, money, and a lot of effort. So most sites actually lack the technical capability to run complex equipment like the stirred mills, the HPGRs, and then the all sorters. Okay, so we look at the microwave assisted comminution. That one has specifically scalability issues. So right now it is at the pilots and lab skills. But overall, looking at all these challenges and barriers, we still know that while the energy benefits are clear, successful implementation requires strong economic justification, robust all characterization and technical skills, and planned integration strategies. So future directions. Looking at the future directions in the industry moving forward is toward more intelligent, selective, and energy-aware communication strategies. And first and foremost, we have AI all over. People are using it to make videos, funny clips, editing pictures, creating, all that. So it's also going to be incorporated, or it should be incorporated in our industry, and more so mineral processing, where AI will be used to enable grinding circuits to anticipate feed variability, because this ore variability is a big issue. If you don't know the characteristics of the ore that you're introducing into your beneficiation plant, it is a problem. You wouldn't know how to go about controlling your process to ensure energy savings, right? So AI will be used to enable grinding circuits to anticipate feed variability before it even reaches condition or reaches the mill stage. Advances in machine learning combined with sensors, online mineralogy, and geometallurgical databases will also allow real-time adjustment of mill speed, media loading, and power draw, as this reduces overgrinding, stabilizes throughput, and also lowers energy consumption. Again, we look at the autonomous grinding circuits, where advanced control system and machine learning grinding circuits can self-optimize, adjusting parameters continuously based on the characteristics and operating conditions and desired products. So the running of the plant won't be heavily reliant on the control room man who is sitting behind the computer. Anything can happen. We have human error. So if we have an autonomous grinding circuit that can know when to increase mill speed, when to reduce it, when to, have the necessary controls in place. It's also going to be really like helpful in energy efficiency when it comes to comminution. Also, we are looking at the cost particle recovery. Can be a major step in change where it allows recovery of valuable minerals at much coarser sizes. This is like can be employed, especially when we have the oil sorter in place, where most of the gang material has been removed, right? So it means whatever you are introducing into the plant is already high grade, right? So if the particle sizes are coarse, it wouldn't like help reduce recovery or have any adverse effects. So the reduction demands on fine grinding, cutting energy consumption significantly, and improving overall circuit throughputs. Again, we will have to look at the integration of renewable energy sources because normally processing plants or mine sites are highly reliant on is like electricity. I was about to say ECG, electricity, right? So we can also look at the inculcation or introduction of solar, wind, and other energy storage systems because it is like increasingly becoming important, especially in countries like especially Ghana, where electricity is quite expensive. So grinding being one of the most power intensive steps in processing and aligning power supply with renewables can drastically reduce both operation costs and carbon footprints, especially in regions with high electricity like Ghana, as I mentioned. And then also, last but not the least, we have the novel breakage methods like the thermal shock, electrofragmentation, electric pulse, of course, the use of microwaves are all emerging technologies that aim to weaken the ore before mechanical grinding. These methods selectively break mineral boundaries, potentially reducing the bond work index. So the bond work index is the specific energy that is required to break down a material. It is measured in kilowatt hour per ton. And also, while still early in the commercialization, these novel breakage methods like thermal shock, electrofragmentation, microwave, and all that, they represent exciting long-term possibilities of energy savings. So it's all of these all point towards a future where communication is more predictive, more selective, and significantly more energy efficient than we are having today. Well, to wrap up on our talk today, the main takeaway is that comminution still, as today, even as I'm talking, remains the single most largest consumer of energy in the mineral processing industry. It often accounts for about 30 to 50% of total site power use, as I mentioned earlier. And because of this, grinding represents the biggest opportunity to reduce energy intensity, operating costs, and overall carbon footprint. The good news is that modern technologies, like we have discussed today, have shown that we can achieve substantial reductions in energy consumption without compromising throughput or recovery. Of course, this is not without its attendant barriers and challenges like we've already seen. And the future of communication is more selective, more intelligent, and far more energy efficient. And the technologies highlighted today are paving the way and the road towards that future. There are other strategies and technologies, but today we just took these four to discuss. Thank you very much for your time and attention. I'm happy to take any questions, comments, or insights you may have. And if you'd like to discuss any of these technologies in more detail or would like to network after this session, please feel free to reach out. That's my email, rebecca.achina@bhp.com and achina@uabeta.ca. Now, before the questions and everything will start coming in, Mr. Entry mentioned that it will be quite beneficial for my experience to share a bit about my journey so that those students or people who are interested in exploring having a career outside of Africa or outside of Ghana in terms of education and also working abroad can also have one or two benefits. So now that the heavy grinding and energy talk is done, I would like to tell you a bit about the real life comminution I went through as an international student to where I am now today. So, like a few takeaways from my journey, I would say I started my journey in Ghana. I went to KNUST. I'm a product of, I'm a technocrat. So, KNUST, where I read mineral, no, not mineral process, it was metallurgical engineering. And after that, I worked in Asanko Gold Mine for like 2 years before I moved to Germany for graduate studies. So in Germany, studying, working, and building my foundation. That's where I would say that confidence is something you build along the way. Even with my background from Germany, because I had already gotten abroad experience before moving to Canada, it felt like starting all over again. New systems, new expectation, new networks, nothing felt familiar. But I had to learn that confidence doesn't show up on day one. It grows with every step you take outside your comfort zone. And every challenge I've faced academically, socially, and professionally has helped shape the confidence I have today that I'm here, like talking to you or having this webinar session. Also, you have to know that motivation has to come from within. Your motivation shouldn't be conditional or situational. It has to come from within. Transitioning from Germany to Canada wasn't like smooth, like you see it. I transitioned from Germany to Canada at a point when COVID-19 was an all-time high, right? Travel restrictions and all that. But I didn't let the pandemic like be an obstacle because my motivation, like I said, wasn't conditional or situational. It was from within. I knew what I wanted and I was laser focused on it and I wasn't concerned about what was happening in my environment. I shot my shot and God being so good. At the time, it was really difficult even to get professors to like respond to emails and all that. But like you said, in Akan language, we have something we say, they are all food we are panel any piano. If you are someone who is willing to improve on yourself, that's when other people can do what help you like improve or grow as a person. So be goal oriented, persistence and consistency are everything. Success doesn't come easily or it doesn't come
Hey,
instantly.
hey, hey, boy. Talk to dustbin.
Okay, thank you. Success doesn't come instantly, right? I had to be intentional, set clear goals, and stay consistent, even when things weren't happening as fast as I wanted. Whether it was networking, learning new skills, applying for roles, adapting to the Canadian environment, to the German environment, I kept showing up, always show up. Even for me to get this time as I'm presenting today, if you ask Mr. Entry, he will tell you. I had to give him like 2 or 3 different dates. I kept changing because of my schedule. But because I'm intentional, I really wanted to come here and share with you so that we can learn from each other. Of course, today we are here having this webinar session. And then one small action at a time. And that consistency is what eventually makes what the difference. Industrial experience is also a game changer. As I said, I've done a lot of schooling, don't get me wrong, but I also made time when I was doing my undergrad. I had internship. I mean, for me personally, I've never had a time that I'm on vacation or I've been idle all the time, right from finishing junior high school. When we're at home waiting for our placement to the senior high school, I enrolled in NIIT where I learned desktop publishing, PowerPoint, Word, and all that. Those days, computer was not really like common as it is now, but I did stay home. I went to learn like desktop publishing, Microsoft Office, and all that. And then right after secondary school, I were waiting to go into the university too. I took some courses in safety, like safety, occupational safety. And then when I was in the university, right in first year, there's no waiting. There's no waiting. If you know what you want, you have to go for it. Right in first year, in the vacation, in our vacation, our first vacation, when I was a fresher, I went to China Gold Mine, CGML. I went to China Gold Mine where I had my internship. And the second year, I had another internship with Anase Lab in in Brofield, Kumasi. And then the third year, I traveled abroad to Germany to have another internship. Final year, of course, after final year, you have your national service. And afterwards, I worked a bit as a graduate training before moving to Germany. So as you can see, every point in time, I have something going on. If you have something, a goal like that you want to achieve, you have to be laser focused on it. You don't have to, and you have to let your motivation come from within. You don't have to sit around thinking, hey, who will come and help? You know, that it doesn't work that way, right? So industrial experience is very, very important, be it workshops, internships, or what have you, national service, any way, anyhow. Even if you have to volunteer to be there to learn one or two things, it's going to go a long way in enriching your CV and your career progression. It also gives you direction, clarity, and a smoother transition into your career. So if you go and you feel like, no, this is not for me, fine. I'm taking mineral processing, I'm taking geology, I'm taking mining, whatever course you are reading, whatever program. If you're on the field and you know what goes into it outside the classroom, you get to know if it is for you or not and which pathway to choose. It also helps with networking. Last but not the least, growth happens outside your comfort zone. I mean, I had made connections, I had course mates, I had a few friends, networks here and there in Germany, but I left all that and came to Canada and I started afresh, adapting, learning, and rebuilding. None of these were easy, right? But all of it was worth it. The person I am today is as a result of every challenge that I have overcome. And I want you to know that your journey too is shaping you into someone stronger, more capable, and more resilient than you think. Thank you so much. So I'm hoping to have any questions, feedback, insights, or suggestions that you may have.
Thank you very, very much, Dr. Rebecca. At this point, I would like to give a brief of what I've learned so far, and then I'll give the chance to the founder for his address. So, comminution includes crushing and grinding, remains the biggest energy user in mineral processing, and it takes up to 30 to 70%. But modern solutions like the HPGR, the ore sorting, and the stirred mills can help us cut energy while microwave assisted comminution shows great future potential. And let's remember the the most energy efficient grinding is the grinding we do not do. That's a quote we can take away. And also, confidence doesn't show up on day one. We build it along the way. Thank you very much, Dr. Rebecca, for these. They'll stay with me forever. At this point, I'll call on Engineer Henry, the founder, for his address. Thank you.
Thank you very much. Can you hear me?
Yes, sir, we can.
Very good. Let me first extend my appreciation to the chairman for this function for making time. And Rebecca, despite the flu, getting through this presentation. I was hoping that she doesn't break down, but she did very well in getting this presentation through. Thank you very much. Before I give my remarks, I want to appreciate two people for their leadership and sacrifices for the chapter. The first one is the Vice President, Okori Banfu Edward, to see all the muting, the organizational collaboration with the various departments and all that has been very fantastic. So a certificate of appreciation goes to Okori Banfu Edward. The second one goes to Mr. Jechi Enoch Barrow, the lead person for the Metallurgy department. He's been fantastic organizing this particular function with his team, almost contacting me every day on direction and so on. So I give you this certificate of appreciation. With that, I want to situate my remarks on the importance of understanding and appreciating the mining value chain, from environmental to geology, mining, processing, other engineering, and so on. And I say this because I started my mining career actually in metallurgy. Right after sixth form, I joined the Pompora treatment plant in Obuasi as a lab technician, metallurgical lab technician. Circumstances beyond my control led me into mining engineering rather than metallurgy, as those who have read my book will know. But that experience at the Pompora treatment plant shaped my career throughout, because I appreciated the role of mineral processing in the entire value chain. Then while I was studying mining engineering at Camborne School of Mines, Obuasi then decided that I should do my internship in Canada. At Camborne, if you don't do 6 months practical experience, internships that total 6 months at that time, even if you have a first class, they give you what we call ordinary degree, which is the equivalent of what we call third class. And so it was very imperative that every student does these internships that Rebecca talked about. So I ended up in Canada on a barrack mine called Camden Red Lake Mine. And in those days, when you go on rotation, the moment you get to a department, they remove one operator and you become the operator. So you're not an observer, you're actually working. So when I went to the processing department, I saw something that I had never seen in my life, which is bacteria and fungi eating out the gang of ore to liberate gold. This is what we call bioleaching. Now, I had never seen it in Obuasi, so I sent a letter to Sam Jonah, the then managing director, that this is what I'm seeing in Canada. And Obuasi was facing challenges with these arsenopyrites and so on. So he dispatched some few metallurgists to the place, and that became the genesis of bioleaching in Obuasi at the time. But fast forward, I found myself as head of operations in various companies, and some of the challenging tasks at production meetings was to see geologists blaming mining engineers blaming processing engineers, metallurgists on why we were not achieving our targets, gold targets, iron ore targets, and so on. And so I challenged these interdisciplinary groups to come up with a concept, which has now transformed into what we call geometallurgy, which integrates geological, mining, and metallurgical data to maximize the net present value of operations. And this has become very well known in the industry now. But I also took a diversification drive. Now, you heard Rebecca saying that she did safety and so on. It is, every time I talk to you, I talk about diversification because I've been in that game and I know how much it has helped me. So my diversification now was to a mineral processing company in Brisbane, Australia called Sedman. And my role was commercial development manager for a mineral processing consulting company. My KPI, key performance indicator, was to grow the company from Australia to South Africa, Mongolia, and South Africa. But you cannot do these things without a clear understanding of mineral processing because it was a mineral processing company. But because of my appreciation and understanding of mineral processing, despite the fact that I didn't have the qualification, it made life a bit more easier. And so when I moved, that was my last role on the technical mining side. Then I moved to the commercial investment side, working for governments and companies and banks. And then it became even more telling, understanding the role of environment, geology, mining, mineral processing, and so on. Now, just recently, I was called in to audit a feasibility study. And when I went in, the feasibility study had been managed by a mineral processing company that had then outsourced the mining engineering geology to other groups, and they sit in as the overall manager of the project. And the first thing I looked at was gaps in the mineral processing. And I remember sitting down with the managing director of the group, and he telling me that he's got 30 years experience in metallurgy. I'm just a mining engineer, and why am I posing gaps in his feasibility study? And so in the end, it went to court because I saw things that had led to financial loss to the client. Throwing low grade away when there is the technology that Rebecca just said, ore sorting, that was able to physically separate low grade from the waste through using sensors, analyzing particles, and using properties like color, density, and so on. So I'm not a metallurgist, but I had an appreciation of all these things. And so finally, they withdrew the case from court and recommended a third party to actually look at the gaps that I have found versus what they claim is a complete feasibility study. And then the revelations were shocking. And so it led them spending another 6 months on the project to tighten up things. Now, I say all these things because when you have the opportunity to learn, to grab knowledge, you have to. I'm still learning. Anytime I attend your workshops, I still learn some few things and so on. So I'm encouraging you to grab knowledge wherever you are, and you never know when this knowledge is going to help you in your future careers. Now, I'm going to challenge you again, the metallurgy group, and even mining and geology. You have a system in Ghana where you have group project work. I'm glad your chairman is also a lecturer. And you see 3 mining or 4 mining engineers doing a project together, 4 metallurgists doing a project together, 4 geologists, and so on. I'm going to challenge you to challenge the status quo and have interdisciplinary collaboration where you have a metallurgist, a mining engineer, and a geologist, 3 departments working together to solve an industry problem. That's how problems are solved. We cannot continue to sit in our silos as geologists, mining engineers, metallurgists doing our own thing. The mining industry is becoming so challenging and complex that if we don't collaborate across sectors, it's really going to be a challenge. The concept of geometallurgy, for instance, where we see a group of professionals working together. These days, energy is key, and that's why mine-to-mill concept has also become a defining moment for the mining industry, where we see crashing, blasting and crashing to liberate energy, to save energy, and so on, across the value chain and so on. So I'm going to use this opportunity to challenge you to sometimes approach your lecturers, authorities to do differently. Your aim is to solve problems. I've engaged a group of mining engineering students to look at academic curricula of Colorado School of Mines versus UMaT. And the intent is to look at gaps and opportunities. I've spent quite some few days in Colorado now doing some guest lectures. And I've been amazed at the things that I've seen. Instead of your usual research, your final year research, they are given projects that allow them to apply what they've learned in environment, geology, processing, mining, economics, all the way to net present value to solve a problem. And it allows them to apply rather than chew and pour and come up with innovations to help the sector. And that's why they've been ranked #1 for continuous years. And so this group undertaking this research will present it to the school authorities, the vice chancellor, on what UMaT is doing right at this time, areas that they can improve, and so on. So thank you very much, Mr. Chairman, and then the speaker for this fantastic presentation. And thanks all for your coming. In fact, you are over 100, which shows that there has been a lot of interest. Thanks for all the organizing team. Thank you very much.
Thank you very much, Engineer Henry. A great journey starting from metallurgy and now into mining. At this juncture, ladies and gentlemen, we are the question and answer session. And I know we all have questions from Dr. Rebecca's speech. So you can all type your questions and they'll be addressed. Thank you very much.
But before you do that, if there are any industry people who want to contribute, give them the time before the questions. I know some people joined from Australia and others.
But, bring the motive.
Bring it.
Okay, sure. Okay, so all industry experts and our guests, you are very welcome. The floor is opened and we are honored to have you here. If you have anything you want to share with us, thank you very much. You can do that for us.
Otherwise, you can continue with the questions, and if they want to come in to contribute, they can do so as well.
Okay, ladies and gentlemen, at this juncture, we can take your questions. So if you have any question, just as stated earlier, you can type them and they'll be addressed. Thank you.
Moderator, there are a few questions on the chat, if you can read them.
Okay, so this is from Inti Benedict Arjun. He said, thank you very much for the great presentation. Please, with the renewable energy sources, are there any big obstacles that prevent the industry from implementing them? Because I've not yet seen any processing industry that relies fully or partly on renewable energy resources. Ms. Rebecca, can you help us with this question?
Yeah, I think for that, it has to do with costs. If in my opinion, right, the capital expenditure, CapEx, it's much more like expensive to get some of these things running. But I mean, the initial cost has greater benefits down the line. But mostly that is what is an impediment, and also skilled expertise and what's not. That's the little I know about that. I mean, we are all learning, so we can all go read more about it and know why it is not as easily used as electricity. Yeah, that's what I have to say about that. If anyone else has another contribution or feedback to it, the person can equally do so.
Okay, thank you very much, Dr. Rebecca. Mr. Inti Arjun, I hope you are satisfied. Thank you very much. From Jachi Inogbano. From Jachi Inogbano, please, considering the future direction of mineral processing, I've learned about the growing role of automation and AI, especially in comminution. How can we prepare, adapt, and position ourselves to stand out in this evolving landscape?
Yeah, so
Dr. Rebecca.
Like Mr. Entry mentioned, right, that he has encouraged the mining department guys to look at the curriculum of the Colorado School of Mines. I think some of these things are not readily available in Ghana or in Africa at large. So if you are interested in growing in machine learning, AI automation, and all that, you can go out to universities or research labs that are already like partaking in some of these things, right to the heads, the professors and all that, take some courses. That's how to better like yourself for the evolving AI that we have in our industry, because you need a skill set. And with a skill set, we need to learn. You have to perform research. You have to, because they are like emerging technologies. Like I did in my PhD studies, I did microwave assisted comminution. It's new and emerging. So you have to break the novelty of it so that you take it from there. If you also find yourself in a place where you already have companies or industries that are already incorporated some of these technologies, you can get an opportunity to do internships, go for field trips or workshops so that you can learn a thing or two. You always have to avail yourself to learn and up your skill sets. That's how come you can be able to fit in. Yeah.
Okay, thank you very much,
I would
Dr.
like to add a bit to what Dr. Rebecca just said, which was a very good answer. The bit I would like to add is you have to understand the fundamentals of the process that you are going to be involved in. What I mean by that is with automation and AI, essentially, that you are going to take large amount of data, process it, and then use it to optimize and run the plant. And where you come in is essentially as a problem solver. When something is not going right, being able to identify and have a solution for it is where you come in. So the day-to-day operations will be run by the automated systems, and then they face a problem, you come in. So we're talking today about the ore variability. So if you understand how the ore can vary, what the variability in the ore, how it would affect things like not just the hardness, things like the sizes that will come in, the distribution of the element of interest in the material. If you understand the basics of this, when you run into a problem, you know where to look to solve the problem. So understanding how these automated tools work is very, very important, but also understanding the applied part. So essentially, if you are in the comminution section or you are in any of the hydrometallurgy or pyrometallurgy sections, the automated process is going to be running it day to day, but essentially understanding why maybe if you're doing, let me move a bit away from comminution to hydrometallurgy where I am more comfortable a bit. If you're doing something like flotation, why isn't your element of interest floating very well? The automated system might say we have to feed in X amount of these sets of reagents, and this is how much feed has to come in, this is how much air has to be pumped in. And then by understanding maybe how the interaction between the mineralogy and the process parameters work, you might say, okay, this is what you're recommending, but this might be some of the changes we should make. So my advice is to understand the fundamentals of what you're doing so that you make yourself into a problem solver. And then I think that's where you find your role in the future of mining. Thank you.
Thank you very much, Dr. Kojo Konadu. So, ladies and gentlemen, if any one of us has a question, the person can raise up their hand and he'll be called upon. This is from Tech Expert Construction. The microwave innovation is fascinating. I'm curious how soon it might become commercially viable, especially for all bodies with high mineral heterogeneity. What are the biggest barriers preventing microwave assistance comminution from being used at scale in industry? Thank you.
Yeah, so thank you for the question. So microwaves penetrate a few centimeters into the rock or ore body, right? Depending on the mineralogy, like I said, the ore has to have varying minerals that have different dielectric properties. So in order to achieve uniform heating and ensure that all particles receive the required energy. But here is the case that mostly we have a lot of ore variability. We don't have the optimal ore, so we didn't know. So right now it's really at the lab and then the pilot skills. And then aside that also equipment durability and material limitations is another barrier. Microwave exposure generates sudden thermal expansions, micro cracking, and shock waves. And these conditions are harsh on conveyors, microwave cavities, and waveguides, right? So the lining and shielding must be replaced frequently. So it means although you're trying to save costs, it's also giving problems like destroying other materials and equipment that are on site. So it's not really ideal at the point. That's why it's still an emerging technology. We are still having research on it to how to make it like optimal or better for scale up abilities. And also all variability, like I mentioned, not all ores respond very well. Some ores have their dielectric properties are not fit enough to undergo microwave treatment. So that's also another point. And also, nobody has really, it's it's a new technology, and no one wants to be the first to microwave 5,000 tons of rock per hour or something like that. So it's still like under study. It's a new and an emerging technology that is still under study, normally at the research level and then lab and pilot levels. I think last year or so, our professor told us that Anglo-American were trying to upscale it, but I don't know how that went, whether they had some roadblocks or something like this. I didn't really follow up again. So yeah, some companies are trying to, like Anglo American, like this is what I know. They're trying to upscale it. Yeah. So it depends on the kind of oil you're working with, the oil variability and all that. Yeah. And I see another question. It said, considering the operational realities of mines in West Africa, what barriers exist in implementing HPGR technology and how can plants overcome them? I think I made mention of this while I was talking about the challenges and barriers. So with the HPGR, like it's highly like it's expensive, right? The capital cost involved in acquiring it is expensive. That is one. And then secondly, most plants already exist. So retrofitting new equipment into it will mean shutdowns, creating new layouts, having to train new people, like getting expertise, expert personnel, and all that. All these, it's all boils down to cost. And remember, we are saying that energy is inefficient, right? So we are trying to make it efficient. It's all also has to do with the cost and everything aside the carbon footprint. So we want to have a fair balance of not having to throw out so much money to have maybe little or no benefits. So yeah, if it's a new mine, mostly the new mining company, like new mining companies in areas are comfortable incorporating HPGR, where they totally take off the SAG mill and then they put in the flow sheets, they put the HPGR before the ball mill, right? So it helps with energy savings because the HPGR gives better energy savings than the semi-autogenous grinding mill. Yeah.
Thank you very much, Dr. Rebecca. Ladies and gentlemen, we are still on the question and answering section. So if any one of us has a question, the person can raise up their hand and be called upon. Thank you.
If you have any questions about how to also position yourself better to further your education abroad, like, I mean, not about the technical bit of combination, but social life and all that too. You can bring it up. If I am able to answer, I will help you. If not, I'll direct you to where you can better find an answer.
So this is from William Cramper. Miss Rebecca, please, how were you able to land your first expatriate role?
Oh, I wouldn't say I'm an expatriate. I'm not an expatriate because I'm a resident of Canada, right? So I'm more or less like a local, and I got a job as a local, as a resident. So it's not an expatriate role because I came to school here and I saw the role. I applied, went through the recruitment process, and I landed the role. So it's not really like an expatriate role per se. Yeah. So he said, has there been any experience mishap and what were the solutions? Like I said, it's still really at the research like stage. A lot of like downs and ups. So personally, myself, I worked on a copper ore, right? Copper porphyry ore. So it's based on the kind of ore or mineral of interest that you are working with. It's not a one cap fits all. You have to know the characteristics of the oil you are working with, the dielectric properties. A lot goes into it. A lot goes into it. So it's not like it's something that has been well established, and then we have mishaps, and we have already ready solutions at hand to tackle them. No, that's not it. Like I said, it's an emerging technology and it's still at the research stage. So how can one transition from one field to another for purposes of grad studies? What preparations can put you at the forefront? First and foremost is motivation. You have to motivated, highly motivated. So if, let's say, I personally, if I'm a mineral processing engineer or a metallurgist, and I would want to move over to mining, of course, I can't just transition and go to the mining department and start working over there. I have to be able to have that kind of motivation, be able to learn, look for other resources that can help me. And also, you have to have a good grasp or grasp of whatever you are doing now, because that will better help you to transition. You have to have an understanding. Like Doc said, you have to have a better understanding and know what you are getting yourself into, right? And after all that, I mean, with grad studies like this, they'll look at something as statement of purpose. What is your motivation? Why do you want to move from career trajectory A to trajectory B? Like, why they need to change career? You have to be able to let them know, convince them on why you want to make that change. But regardless, you have to have the rudiments of it, the basic like requirements. As I sit here, I can't just go and apply and will say I'd want to be a surgeon or a medical doctor. No, I would have to take certain courses, the basics of it. So if you don't have the basic knowledge of what you want to transition into, I think it's going to be quite cumbersome, right? So you have to know that you have to get the basics of it, have an understanding, have the motivation before you like venture into it.
Okay, thank you very much. From Kojo to Philip Jr., he says during the founder's address, he mentioned of geometallurgy. I have had field trips and interned at various mines and mineral labs, but I didn't hear or see geometallurgists available. Is it that it is not an established role here, or they can only be found outside of Ghana? To Engineer Henry, thank you.
Yeah, that's a very good question. I'm not too sure. The last time I had an engagement with one of your graduates, she was trying to position herself after a graduate trainee. And she told me the competition was very keen. And so I advised her to do some research in the area. She went to her supervisor and then asked about it. And she said it was all being done from the United States. And so she used that opportunity to position herself to learn more and coordinate things between Ghana and the United States. And that's how she made herself competitive to go from graduate trainee to the next stage and so on. So the fact that you cannot find them in Ghana doesn't mean that it cannot be done. More likely, the expertise are sitting in corporate offices in Australia, Canada, and the US doing that type of work. Because I know Newmont does some geometallurgy, other companies do some geometallurgy. So maybe the expertise have not come to Ghana yet. And so it's an opportunity for some of you to do your project work in those areas. That will mean a more collaborative project work across departments, and that can position you for these roles. Last week, I mentioned one of your colleagues in Obuasi, where there was no role in occupational health, for instance. When she saw something on my status about occupational health in Australia, he jumped on it, and has been able to craft a position on occupational health in Obuasi for himself. So these are only a few examples of how you can position yourselves, especially in this competitive work environment.
Thank you very much for that very good answer. And I would like to add a bit onto that. So I think that's something that we have also recognized as a bit of a gap in the learning of our students. So it's something that we've tried to fill. So we introduced a course in the undergraduate program, which is process mineralogy, trying to essentially try and connect the metallurgy that you're doing with the mineralogy and then the ore composition, trying to bridge that gap so that you understand how whatever process that you have is influenced by the material that is going to come in and how the variability in the material is going to really affect your ability to gain it. So we hope, I think the first batch that took the course just graduated this year. So we hope that with this introduction of these courses, we're also trying to introduce more courses that aim at teaching you the analytical part of the process, because geometallurgy, you have to be able to analyze the material you have so that you can see how its variability is going to affect your process. So these are some of the changes that we are continuously implementing, and I think we'll be able to produce our own crops of geometallurgists that can connect whatever process they have with the material that they are working on.
Thank you very much, Dr. Kojo Konadu. So to Ms. Rebecca, what advice do you have for those of us who have never had a place for internship, since it's mostly about knowing someone in the industry before you can secure yourself a slot? Thank you.
Okay, I understand the situation. I think it's all about exposure and networking, right? So it's a really tight and difficult one, but you make do with what's available to you. So you can use tools like LinkedIn. LinkedIn, like this is a place where you can network with professionals in your career path. Aside LinkedIn too, you can also send out cold emails. When I say cold emails, I know it's in Ghana, it's a bit tricky, but it's nothing. You don't lose anything if you don't get a response, but you don't know what you can get, right? So you can send cold emails to companies. You can check company website to see if they have internship. Sometimes they don't even have internship roles available. Like I said, if you send a cold email, hello, my name is so and so. I'm a student, second year, third year, whatever of this school. I'm reading or this program, this and this and that. We have a bit of break, and I would really like to, something short and then straight to the point, precise. You don't know which email it will land in. Mostly like HR or talent acquisition crew of companies have their emails available like on their websites. So you have to do a bit of searching. I know in Ghana it's who knows you. It's not even who knows you and is willing to help. There are people who even know you and they are not even willing to help, right? So who knows you? But that's a bit like on the tricky part. But like I said, use the tools available to you. And Doc mentioned also that they are trying to introduce some program where students can be able to go out there to the industry and then maybe workshops, internship. It doesn't have to be only internship. It can even be a seminar like we have now, like this webinar that we've all joined. I don't know who is here, but you can go through the list. Myself, I put out my email. So in case, I'm not saying I have internship opportunities. No, don't get me wrong. But in case you need any advice or mentorship or, something that you feel like can be of help, you can shoot me an email. Unfortunately, I am not on LinkedIn. I told Mr. Entry, I've really been off radar on social media, LinkedIn inclusive. So I used to be there, but not anymore. I think I spoke with him and I will think about coming back soon. So yeah, that's it. Make use of the tools available to you, and then I think that should help.
Vibes.
Thank you very much, Ms. Rebecca.
Let me add a bit to what Rebecca said.
Bullying you live there.
Like it's a character here. Okay.
Let me add a bit to what Rebecca said on these internships and so on. So the questioner is right. Sometimes you need protocol. But based on my experience with a lot of you, students, graduates, most of it too is not protocol. I'll use the KNUST example because I was told that that's how they do it. They do it by CWA, whatever you call it, academic score. And so when the mines send the slots, they go by a system whereby the highest scores are allocated to, let's say, Anglo Gold. Then it goes to Precious. Then it goes to Gold Fields. then you go to other industries and so on. I know UMaT too, they have a training officer for a lot of your courses. They get the slots and then they allocate. I don't know the formula that they use, but more likely is a KNUST system. I say that because I talk to the industry more than you guys. I talk to almost all the general managers in the industry about these internships. And most of them tell me that to avoid all these protocols, corruption, and all that, they tell the universities, we want 5 mining engineers, 4 metallurgists, 3 geologists. The universities go through their own system and bring them. And then there is the community element too. The communities also are allocated slots. For instance, WhatsApp, for instance, will say out of 30 slots, we are going to allocate 15 to members in the community and so on. But I want to challenge you because there are other ways of getting interest or doing internships. I had an AusIMM president who was in 2nd year, and all I did for her was to give her a project that will allow her to collect data, extensive data from a mine. So she ended up going to a great prime mine for 4 vacations, 4 internships, or 4 data collections. And those data collections were so practical. She had to sit in trucks and do cycle time analysis, go into their database and look at productivity of equipment and so on. By the time she finished, she already had a national service job. She didn't take it, she went to UMaT, but they were pushing to hire her and so on. So you have to be a bit innovative in the way you go about things. Some people will say, oh, it's the school didn't allocate me, so I don't have a place. But it's not all companies that send slots to the school. The small scale mines don't do that. So you can easily apply to a small scale mine, and you don't need a letter from the school to go to a small scale mine. Other industries don't require any letter, or they will take you and tell you to go and bring the letter. I was on the board of a company where we don't send slots to UMaT or KNUST. But if you apply, hold email like Rebecca said, and we assess it, we then tell you that we have taken you, go and get a letter from the school to come to that company and so on. I'm on the board of few companies in Ghana, and now I'm telling them, look, anybody who shows interest, go through a proper process, interview, and then give them opportunities and so on. So you have to be a bit innovative. Now, internships are good if you can get your area of expertise. But if you don't, you still don't sit and do nothing, like Rebecca said, learning, safety, and so on. I happen to work in a charcoal manufacturing company as a mining engineering student because I didn't have a place. And I learned how to do charcoal. And it helped me getting additional funds when I was going to school and so on. I know of a friend who chaired one of our functions, Erica Subonte, for instance, telling me that on one of his vacations, he just took a backpack and was knocking on doors. He traveled, he walked across Kumasi, knocking on doors. This is my CV. This is my CV. Out of about 50 companies, one gave him an opportunity, so he didn't stay home. But if you just sit and say it's protocol, and therefore I don't know anybody, and therefore I'm not going to get an internship, then you sit there for 4 years and you might not even see a mine before. In fact, I was so sad when a final year mining engineering student told me that she had never seen a mine before. And so I had to, out of sympathy, call a general manager and give him that notification. And he came from Kenya, one of the Newmont places. He still couldn't use the community thing to get into a mine to do internship. And so the general manager of one of the mines, out of sympathy, said, oh, this is bad. So he gave her 3 weeks internship and so on. So use project work, because I know 2 students who are working on the projects, and all they did is write to a mine, and they said, come, it's not their final year project. This is a project that a geomatic engineer and the geologists are working on. They wrote to a mine, and they were given opportunity to come. So even though it's not internship, they get opportunity to go there, collect data, see the mine, network, and get to know people. So be innovative. And when you get opportunity to use it, I was at KNUST doing a public lecture, and then one of the students said he was at GMC. And based on his experience, if you don't have any protocol in GMC, you will never get an internship or even national service. Now, unfortunately for him, I was with the AusIMM president who had also done internship at GMC. And this was a big platform of lecturers, professors sitting there. And I had to address it. So I said, Daniel, you work in GMC. Come and tell us your experience. While the KNUST student was just there doing his normal routine, going on vacations, Daniel had actually picked a project that he was working on to add value to the company. And so when he finished, that was the first place he had his national service. They called him up. You can come here. He didn't have to even apply and so on, but he didn't go there anyway. So take advantage of these things and don't just go there and be an observer and go through your rotations without adding value. By all means, you can pick a concept and discuss with the supervisor there and either make it your project work or work on it privately while you are there to make yourself visible to the supervisors and so on. So that's the advice that I can give. Thank you.
Thank you very much, Engineer Henry.
Yeah, hello.
Hello.
Yeah, so just a bit to add on to what Mr. Henry said. Yeah, so that actually happened on a public lecture at KNU yesterday, standing over here. And then that project, despite it giving me opportunity to have my NSS at GMC, of which I didn't go there, during my interview for GTU at Anglo Gold, I was able to use that story to sell myself, which was a big plus in securing my new role as a GT at Anglo Gold. So all these exposures are what is truly going to sell you in your next endeavors. So it's very important that when you go on these internships and attachments, you try to add up the little value that you can. You don't know where it will take you. Okay, thank you.
Thank you very much, Mr. Daniel. So, ladies and gentlemen, we have had so many accounts about how not sitting idle can help us. We'll take the very last question as we end our question and answers. This is from Prepra. He says, I'm a chemical engineering student and my internships have shown me how fascinating metallurgy can be. Thank you for the insightful presentation. Could you explain how the circular economic approach, such as recovering waste heat or using recycled grinding media, fits into the roadmap for optimizing energy efficiency in comminution? Thank you.
So this circular economy thing, it's broadly common in Europe. I remember when I was in Germany, it was always a conversation. Not so much in North America, but in Europe. So I have a fair idea of what you mean. So with circular economy, it normally asks, so example, like when I was doing the presentation, I mentioned that most of the energy introduced into the conventional milling circuits, like the sag mill, ball mill, are dissipated as heat, noise, vibration, overcoming friction, and whatnot, right? So circular economy is something that will ask, how can this wasted energy, the energy that is being wasted, that is not being used to break down the rock material or the ore, how can the energy be recaptured and used for benefits, right? So let's say something like the wasted heat like this, it can be trapped or to use to have preheat water, processed water or slurries, reducing the energy needed in downstream processing. Example in flotation, thickening, or tailings handling. Also, we can use the recovered heat, meaning we have to find a way of recovering this heat because normally it is lost into the like environment or the atmosphere, right? So circular economy like this, you have to find ways and means of recovering the wasted heat and reusing it for something beneficial. So that's how, from my understanding, that's how like this can be incorporated. Circular economy can be incorporated in energy efficiency in comminution. Yeah, that's like the little I have to say about it.
Okay, thank you very much, Dr. Rebecca. At this point, we will end our question and answer section. It was a very, very educative section. We will take the chairperson's closing remarks. So to Dr. Kojo Konadu, thank you.
Okay, thank you, moderator. Thank you all for being here today. I would like to thank Dr. Rebecca for making the time to be here and share expertise on comminution, some of the ways we can improve it, and our role in it in the future. So thank you very much for making the time. I would like to thank you all for making the time to be here too, to learn about this process. So I guess you've all learned how integral comminution is to the mineral processing structure in the entire mineral processing structure, and then how even small tweaks and changes in it can achieve significant reduction in cost of operation. So I think I'll also like to thank the founder for organizing this chapter to try and introduce all of these people to how the mining industry can work on a practical scale, essentially. So thank you all for making the time, and I hope you have a nice day.
Thank you very much, Dr. Kojo Konadu. We will take the vote of thanks and closing prayer from Miss Abigail Amwabin to 4. Thank you.
Okay, so good evening, everyone. On behalf of the Metallurgy Department, I would like to express our sincere appreciation to everyone who made it to today's webinar. Yes, first of all, I'd like to thank God Almighty for giving us today and for making today glorious. A very big thank you to our founder, Engineer Henry, for his vision and his support towards this event. I would also like to especially acknowledge our guest speaker, Ms. Rebecca, for sharing valuable insights with us and for helping us understand the topic very well. We really appreciate your time and your contribution. So to our chairman, thank you so much for honoring our invitation. We really acknowledge your presence here with us. And to the Metallurgy Department, I'd like to especially appreciate you all for your support and your hard work and your good work. Everything that you have done, you have made this webinar a glorious and a successful one. Now, to everyone who joined us today, we really appreciate your presence here. Thank you all for your time, your interest, and your participation. We are really grateful that you joined us today, and we hope to see you again in our subsequent webinars. Thank you all so much. So we will end this session with a word of prayer. So please, we are praying. Our Heavenly Father, we thank you so much for today. We thank you for giving us this day and for making it glorious. We thank you for a successful webinar. We pray that you continue to be with us and you continue to guide us. Continue to bless everyone who made it to today's webinar and continue to direct our path. Till we meet again, continue to protect us in the mighty name of Jesus. Amen.
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 Amen. Thank you to Dr.
So,
Rebecca.
yeah, I have something to say. So I saw that some people were asking for the slides, right? I've shared it with Enoch, so anyone who is interested in this can get it from Enoch.
Okay, thank you very much. We'll do that. So thank you very much, Dr. Rebecca. Thank you, Dr. Putin. Thank you, Engineer Henry. And thank you, Enoch Jeche, for being the host for today. I must say to Clifford, your moderator for today. Thank you to each and everyone. Bye.